Hello everyone, and welcome back to Coding with Muck. In this video, we'll be looking at problems using Java concurrency or Java multithreading. Now, in the first video of this series, I've explained to you in very few words what concurrency actually is. I said then that concurrency is when two things or two tasks are running at the same time. And that definition still applies. Now, when do we get concurrency problems? We get concurrency problems when those two or more things that are happening at the same time are happening to the same things. So if they share something between them, that's when problems will start arising. Now, that might be a bit abstract for some people, so I have a little example to show you. I have a simple class here, a counter class, very simple class with one variable, one class member, a private int counter here, very simple int, and two methods. One is a getter, even simpler, and an add method. And the add method, the only thing that my add method does is basically add one to my counter. So every time I call my add method, my counter gets incremented by one. That's all it does. Okay, now in my main method, let's create a counter. We'll instantiate the counter as we've always done. And now let's make two threads, two really simple threads, T1. And let's use lambda notation to create this. And in my, what do I want to do in my thread? I want an int stream that calls the add method 10,000 times. So for each I, what do I want to do? I want to do counter. That's all I want to do. So in my thread, I'm going to create an int stream, and my int stream does something 10,000 times. What does it do 10,000 times? It will call the add method for my counter. Okay. Now I'm going to do this twice. So I'm going to create two threads that do the same thing, right? So they're going to be sharing the counter instance or the counter object between them. So my first thread here is going to call the add method 10,000 times. And the second thread is going to do the same thing. Now, while I'm finishing off my code here, think about, or just try to guess what the outcome will be. What will be the eventual number that you can find in my counter? Now I'm going to start my two threads really quickly, and then I'm going to pause my main thread by calling the join method, and then I'm going to ask my counter what the eventual number is. Now, quick explanation of the join method here. The join method will pause the current thread, so not T1 or T2. T1 and T2 will not be paused, but the thread that is calling this method is the main thread. So the main thread is going to get paused. How long will it be paused? It'll be paused until T1 is terminated or gets to the terminated state. Now, if we look at the documentation, waits for this thread to die. It's quite dramatic, I know, but the thing you need to remember is the join method will pause your current thread, and it'll wait for this method to finish. That's all it does. Then it'll go on to the next line. So now I'm saying t2.join. So my main thread is going to wait till thread 2 is in a terminated state, and then my main thread will continue working. So basically, my counter.getCounter will only be called once T1 and T2 are done with their work. Okay, that's about it. So, who of you guessed that the eventual outcome will be 20,000? Because I'm hitting the add counter 10,000 times using 2 threads. Who thinks it's going to be 20,000? Write in the comment below. Okay. Let's see if you're right. Let's see if you're correct. We're running our code, and the eventual result, 12,552. I can hear some of you scratching your head from here. Let me make it even more interesting. Let's run our code again. 18,000. Getting closer, but not right there yet. Let's run it again. Again, 12,000. Run it again. 16,000. Well, almost 17. Run it again. 17. 13 to 48. This is the big issue with concurrency. When you have a shared resource between 2 threads and you want to alter or modify or mutate something in that resource, that's when you start running into concurrency problems. And when we as developers will have to start thinking about multi-threading in a little bit of a different way. Okay? Now, the solution will be quite simple. But the thing is, we as developers, and especially you as junior developers, will have to think about when am I in a multi-threaded environment, and when are you using a shared resource, or when are your threads using a shared resource. That's the really important part. Okay. Um, Later on, in I think in a few videos, we'll be looking at are we actually using multi-threading? Now, the thing is, as junior developers, you will probably not be asked to implement multi-threaded solutions, but your code will be used in a multi-threaded environment almost always, right? So the reason for that, we'll be looking into that in future video series. Once we get into web-based applications, that's where multi-threaded environments will become very important, or thinking about multi-threaded environment becomes really important. But in this fundamental series, you don't have to worry about it as much. But we still need to know how to solve this issue. Okay. Now, solution is quite easy. The problem that we are facing here is because we have 2 different threads trying to access one resource at the same time. Okay. Now, I could go into a really technical discussion with you guys and explain to you technically why this particular thing goes wrong, but we don't have time for that at the moment. But what you need to know is that this happens because at certain times, T1 and T2 are trying to access the counter right at the same millisecond or even nanosecond. And that's where the problems start popping up. So if the problems come from 2 threads or multiple threads trying to access our shared resource at the same time, we have to prevent that from happening. We have to say, or we have to build something into our shared resource that says, hold on, guys, I'm working with T1 here. T2, you're going to have to wait, or the other way around. The way we are going to do that is we're going in our shared resource, and at the moment, that's our counter here. But this is a really simple example. Later on, we'll be seeing that this can happen on multiple levels and really, or in more difficult situations. but I'm trying to explain the concept here. In our counter, the solution is I can add a keyword here that says synchronized, and this synchronized keyword says, okay, when one thread is executing this code, no other thread can execute this code. Now, we don't have to, as developers, we don't have to manage all of that. That's being managed by the scheduler in the virtual machine. So he takes care of all of this. But the only thing that we have to say is, okay, this code can only be executed by one thread at a time. Okay, now let's see what the result is if once I add this synchronized, and as you can see, 20,000. Let's run it again, 20,000. Run it again, 20,000. One more time just to be sure, 20,000. Okay, so this is good. This is what we're trying to achieve. Our synchronized keyword fixed our problem. Now, basically what we did is we had a multi-threaded application. And now we're saying for our resource, you're going to have to get in line. So if you would be looking at the performance charts of this application, you would be seeing a drop in performance. That's normal. But we don't have any bugs anymore. That's a good thing. Okay. Now, there's another way to fix this, also with the synchronized, and we'll be looking into that in the next video. Okay. So for now, synchronized on a method will prevent multiple threads to access this method simultaneously. Okay. In the next video, we'll be looking a little bit deeper into the synchronized method. Instead of synchronizing complete methods, we can also synchronize code blocks, right? Okay, but we'll be looking at it in the next video. Okay, try and make some exercises, look into this, and I hope you understood. If there's any questions, post them below in the comments. Goodbye, and be safe.